This video is an intro to SEM. You'll see SEM throughout the remainder of our year together, and also for sure on the AP test if you intend to take that. SEM goes along with graphs and data. It allows you to more accurately interpret the information given to you on a graph or data set than opposed to maybe those that you have seen in other classes before this one. We're going to go through page 1, part A together, and then you'll be on your own to try part 2, and then there will be more continuing on with this next week. What you're given on the front here is a bar graph, like those you have traditionally seen, with one major difference, which is these little I bars here. It tells us that a student tested the effect of different mouthwashes on bacterial growth. She had 3 plates, 1 contained bacteria only, 1 contained Equate mouthwash, and 1 contained Colgate Kids mouthwash. She repeated this experiment 10 times, so she had 30 total plates, and her averages are here in the graphs. So we will begin by answering the questions and then exploring the new information given to you by those I bars. Question 1, using the graph, what is the average percent of plate covered for bacteria and Equate? I'm going to read that the good old-fashioned way. I'm looking for the height of the bar. That bar is at about 20, so I'm going to put that as my answer. B, bacteria only. I'm going to eyeball at about what that is. I'm going to say about 27%. And then bacteria and Colgate Kids, height of that bar, I'm going to say is at about 21%. Question 2, based on that information alone, does Equate anti-cavity reduce bacterial growth? Well, if I compare, that Equate plate had 20% growth, bacteria only had 27%. To me, that seems as though there is a decrease of 7%. So I'm going to put that as my answer for number 2. I'll spare you of watching me writing out that answer. So answer for 2 is yes. Based on the averages, the Equate plate was 7% less covered than the bacterial growth plate. Question 3, based on, again, question number 1, I am being asked, does Colgate Kids reduce bacterial growth? Colgate Kids is at 21%. Again, my bacteria only plate was 27%. That's a decrease of 6%. So I will again say yes. Colgate Kids seems to reduce bacterial growth. It has 6% less of the plate covered by bacteria. For both of those, make sure that you explain them. Continuing on, question 4, standard error bars. Now we'll get into the new information for you. Maybe you've seen this before, but most of us probably have not. In AP Bio, we always use standard error bars represented as 2 SEM. What that means is that it's 2 standard errors of the mean. Well, what does that mean? So standard error tells you how spread apart the data is. So it's a measure of how much variation there is in the data. If I were to be comparing, let's say only 3 plates, so instead of 30 like represented in the graph, I'm just going to narrow down and focus on 3. So if I was looking at maybe 3 plates and one of them was 10% covered, one of them was 20% covered, and one of them was 30% covered, and I wanted to find the average, I would simply add those up and divide by 3. I would find that on average, my plates were 20% covered. If I had a different set of 3 plates, and those 3 plates were 19, 20, and 21% covered, if I were to find the average of those 3 numbers, again, I would find that the average was 20% coverage. However, with these data sets, comparing these 2, set number 1 is much more spread apart than set number 2. That leads me to conclude that the set 1 data is a little bit less reliable. If I were to look at a 4th plate, there's a pretty wide range in which that 4th plate might possibly be. Whereas in data set number 2, if I were to look at a 4th plate, I might feel more confident that my 4th plate would be pretty darn close to about 20% covered. So in comparing those two data sets, set number 1 is very spread out, set number 2 is not very spread out. I can represent on my graph how spread out my data is. And I do that with these error bars that are shaped like eyes. A small error bar, I'm looking at the height of the eye here, indicates to me that the data set was pretty narrow and almost all of the averages fell pretty close to one another. On the contrary, an eye bar that is bigger or taller indicates to me that the data is more spread out, and thus my average might be a little bit less accurate and is a little bit less reliable. So a small error bar indicates to me that the average is pretty accurate of all of the samples. A larger error bar indicates to me that the average isn't really that accurate. So then to answer that question in number 4, the error bar is used to tell me how accurate my average is. And that is determined by how spread apart the data is. There is a math formula that you could calculate exactly how big is that error bar and how small is that error bar. This class, AP Biology, does not consider that calculation to be a critical component of the course, meaning that you don't need to be able to calculate that error bar. Rather, you just need to be able to read and understand it. So if you take AP Stats or go on to take other statistics courses, you can pretty easily calculate how high that error bar is. It's just not in the scope of our class, so I'm not going to get into the math of that. Continuing on, question number 5 is asking me about if the error bars overlap. When I'm comparing two data sets, if I see that they overlap, that tells me that since the averages maybe aren't that reliable, there really is no statistical difference in the data. So if I see error bars overlap, it tells me the data is statistically the same. And if my error bars do not overlap, that then tells me the opposite. The data is statistically different. So let's relate that back to our graph to wrap up these last few questions. Question 7, does equate anti-cavity reduce bacterial growth? Looking at my graph, I'm going to compare, and now this time I will look at more than just the averages. I will look at the height of those eye bars, which I call SEM bars. I'm simply going to identify, do those SEM bars overlap? That particular question is asking me just about these two, so that's where I'm going to be looking. I can see that my first bar here ends at a height of that, whatever we want to call that, about 23-ish. And the error bar for bacteria only actually ends at the same point. I would call that an overlap. Any overlap, big or small, is an overlap. So it's like black and white. It either overlaps or it doesn't. So if those I bars touch, if those SEM bars touch at any point, that is an overlap. That tells me then that that data is statistically the same. So then for number 7, does it reduce bacterial growth? I would say no. The data between equate and bacteria only is the same. There is no difference between those averages. Based on that, I would then say using Equate mouthwash does absolutely nothing. The data is the same. Please note, I made this graph up. It's not based on real trials. Lastly, question 8, does Colgate Kids mouthwash reduce bacterial growth? Now I'm going to take a look at my other set of data. And now I'm going to compare those. So this time I'm going to be looking at these two here. And I am looking for, is there any overlap in those SEM bars? These do not overlap. I didn't do such a good job drawing that. But these do not overlap. So I would therefore say that Colgate Kids does statistically reduce the amount of bacteria on the plate. So to answer that final question there, question 8, does Colgate Kids mouthwash reduce bacterial growth? I would say yes. The error bars do not overlap. And so there is statistically less bacteria on the Colgate Kids plate. To conclude, reading these bars does get kind of repetitive. You're essentially looking always, is there an overlap or not? If there is an overlap, that tells you the data is statistically the same. If there is no overlap, that tells you then that there is a statistical difference. How those error bars are made is based on how spread out the data set was. A more spread out data set will lead me to a larger SEM bar. Data that is more all centered around the same numbers would lead me to a smaller SEM bar. To conclude, to complete the back, you'll take a look at this plant graph here on the top right, identify if those bars overlap or not. And then in question 10, you will need to make your own graph. There's no true hard math calculations for you to do. AP Bio gives you the 2 SEM numbers. So essentially you'll be creating a good old-fashioned bar graph with certain heights, and then you will draw in the I bars extending higher and lower than the top of that bar. I did one of them for you in number 10, so hopefully that makes sense. If not, please reach out for help.